Welcome back. This is lesson 7 of Machine Learning Zoomcamp session 10. And in this lesson, we will deploy the TensorFlow model and the gateway service to the local Kubernetes we set up in the previous lesson. We used kind for that. So now we have a local Kubernetes cluster. We already experimented with this cluster. We deployed a simple service, and now we will use that for deploying the TensorFlow serving model and the gateway service. To remind you, this is how it looks. We have TensorFlow serving service, which is a service written in C++ by the TensorFlow team. It is used for serving TensorFlow models. And we have a gateway service. This is the service we wrote. This is in Flask. And the purpose for this service is to get an image, resize it, then prepare the matrix, then NumPy array X, and then convert it to protobuf, and then use gRPC to communicate with TensorFlow serving. And then it's also doing some post-processing. We also mentioned that one of these services, the gateway service, should be an external service, and the model service, this TensorFlow serving service, should be an internal service. So it can be used only within the cluster, and the gateway service should be available outside of the cluster. In the previous lesson, we already deployed a simple service. So if now I use kubectl to see what pods are running on our cluster, we have this ping pods from the ping deployment, and then we can also see what are the deployments. So we have this ping deployment. Okay, now let's deploy our TensorFlow serving model. Also, remember a few lessons ago, we created this Docker Compose config where we run both the model and the gateway. And essentially what we want to do now is replicate that. So we want to deploy the clothing model using this image, and we want to deploy a gateway using this image and provide also this configuration. But this time we want to deploy this to Kubernetes. Let me create a folder here called kubeconfig, let's say. And then in this folder, I will create the YAML files for configuring the deployments and the services. Let's start with creating a deployment for the model. I'll call it model deployment YAML. And then again, I will use a template from the Kubernetes plugin I have in my Visual Studio Code. So I'll just write deployment, and then it suggests me to use a template. And the name for this deployment will be, let's say, TF serving clothing model. It's a little bit long, a little bit verbose, but it makes it clear that we use TensorFlow serving here, and this is a clothing model. So the image for this is, let me open the file with commands we use. So the image, and this one, Zoomcamp 10 model exception v4001. So this is the name of the image. And then for resources, I'll give it 1 CPU and maybe 256 megabytes of memory. I don't know if it will be enough. Maybe let me try to give it a little bit more. Probably I should give it even more, but I don't think I have a lot of RAM on this computer. There is not enough RAM. I think if you give it more, it should be a bit faster. But yeah, let's try with 512 megs and 1 CPU. And then the port that we have on the container is 8500. This is the port where TensorFlow serving is listening for gRPC requests. And one last thing is we need to specify the number of replicas, how many pods we want to have in the deployment. So I'll put 1 here. Yeah, I think that's all we need to do. Before we do kubectl apply and apply this file, create a deployment, we actually need to make this image available in kind. So kind sees this image. Let me check again what is the command for that. So the command for that is kind load, should be something else. It's kind load Docker image. So it's kind load Docker image, and then this thing here. So copy it and execute this command. Okay, now it is made available for our local Kubernetes cluster. What we can do now is we need to go to this kubeconfig directory. We have this model deployment config there. So now I'll do kubectl apply -f model deployment. Now it says, okay, this deployment is created. Let's do kubectl get pod. So now it is initializing it. So status is pending. Let's try one more time. It's pending. Let me check if everything is fine. So I'll do kubectl describe pod and then ID of the pod. We see this message that there are not enough CPUs. So perhaps, I don't know why, but let me try to give it 0.5 CPU, not 1. Do kubectl apply again. I pre-configured it, and then let me do get pod. Okay, now it's running. So while we're here, I don't know how many CPUs is actually available for the kind cluster here, but let me give less CPUs to this ping deployment. So open ping. I still want to keep it running because I want to use it for experiments, but let me give it only 1/10 of a CPU. I don't think it needs more because all it does is just replace with Pong. Maybe it even needs less memory. So let me reapply this. kubectl apply -f, and then I go one level up, then ping, then deployment, kubectl get pod, and now it will remove this, and now this will be created. Deployment. I'm not sure why this one is not being removed. So let me remove the deployment and then recreate it one more time, because I think it doesn't have enough resources, because this one uses 0.5 CPU, this one uses 0.5 CPU, and perhaps only one CPU is available. So that's why they're kind of fighting for resources. So let me just remove the deployment and create it again. For that, what I will do is I will do kubectl delete -f and then path for the deployment. So now it deletes the deployment. And now if I do get pod, it is terminating all these pods. And now I just do kubectl apply again. And now both of them are running. And what I want to do now is I want to test if this TF serving clothing model actually works. For that, I will again use port forwarding like we did last time. kubectl forward, then the name of the pod, and then it runs on port 8500, and then we map 8500 with 8500. Now it's forwarding. Now what I want to do is I want to use this gateway.py again for testing it. What I will do is I will uncomment this thing and comment this. So instead of running the Flask application, I can just send the request and test if things work. So I will go here now and do Python test.py. I think it should be Python gateway. Right. Yeah, it takes some time, I think, because maybe we didn't give it enough CPUs, and this machine, as you see, is not super powerful, but if we give it more resources, it will run faster. So if you run it on your local computer, then you can give it 1 GB of RAM and 1 CPU, and then it will be very fast. Okay, we see that it works. So let me stop it here. I'm not sure what this error is, but yeah, it works. So we created a deployment. The next thing we want to do is we want to create a service for this deployment. So let me create a model service YAML. Then again, I start typing service and then I get autocomplete. And the service, the name will be, I'll just use the same name here. The name will be TF serving clothing model. So the port is 8500 and target port is also 8500. I think that's all we need to do for configuring service. We do not specify type here. The default one is cluster IP. We don't specify it, and the default one will be used because this is an internal service. Let's apply it. kubectl apply -f model service. Okay, now the service is created. So we can do kubectl get service, and we can see that we have this TF serving clothing model, which is a service of type cluster IP. It has this port. So again, we can test it. What we can do is we can do port forwarding, but this time for the service. So let me do this. So I do service slash name of the service then I execute the same thing. It still works, which is a good thing. Yeah, I think this has to do with using gRPC. gRPC is a bit different from usual HTTP. So I think that's why we see this error message. I'm not sure exactly what it's telling us, but yeah, we can test it locally. We see it works. So let me stop it. So we were able to take care of that part. Now we need to take care of this part and also deploy it to Kubernetes. Let's do that. So let me create a new file. I'll call it gateway deployment YAML. And then here I write deployment, and then I'll just write gateway. All these things, all these names are gateway. Then I don't remember the name of, yeah, so it's Zoomcamp 10 model, no, not this one. So it's Zoomcamp 10 gateway 002. So we need to load this. So kind load Docker image Okay, it finished. We need this name. So the name of the image is this one. I think I'll give it just a little bit of CPU, so it will be slower, but it should hopefully work. And then the port on the container is 9696. Let me open our Docker Compose file. In Docker Compose, we have this port thing. And then the other thing we have in Docker Compose is this environment variable. So we also need to set this environment variable in our YAML file. For that, there is another section in the config called env. And then in env, we have name. So the name is tf serving host. And then we have value here, and value is, so here in this case, we use this clothing model. This is not correct. We need to use a different name. What we want to do, we want to configure this pod, and we want this pod to know how to send a request to TensorFlow serving. So as we discussed, what it's doing, it's now sending requests to this TensorFlow model service, an internal service that we deployed. So we need to have the URL of this service now for this pod, for the gateway pod, to be able to reach the service. So let's set it. There is a convention for specifying URLs of services in Kubernetes. All these URLs follow the same pattern. So the pattern is, first we have the name of the service, then we have dot, then we have default. So this is actually a namespace we run in. We will not cover the concept of namespaces here in this session, but you can read about this in official documentation. Basically, this gives us a way to put related things in different parts of our Kubernetes cluster. So the default namespace is called default. That's the name of the namespace. Then we write SVC. It's short for service. We always need to write SVC. And then we write cluster.local. So that's the pattern for URLs for services in Kubernetes. And then the name for us, let me check. It's a model service. So this is the name of the service. So let me put it here. So it's tf serving clothing model .default .svc .cluster .local and then the port. And before we deploy, we can actually check if this works. So what I want to do now is I want to log in to one of the machines, one of the pods. If we do kubectl get pod, we have a bunch of pods here. So what I want to do is I want to log in to one of the pods and execute a few commands there. So I want to get on this ping deployment something. For that, I want to execute a command, and the command will be bash. And this effectively will give me access to the terminal of this pod, and then I can execute any command I want there. So let me do kubectl exec, and then we do this -at like in Docker, which means that we want to be able to give some input and then have access to terminal. I think IT stands for interactive terminal. I'm not exactly sure, but this is the same key we used in Docker. And actually Docker also has this exec command. Then we need the name of the pod. Here, what we say, we want to execute something on this pod and we want to make it interactive. And then we need to put two minuses. Here we are telling kubectl that everything that comes after these two minuses is a part of the command that we want to execute. The command we want to execute is very small. It's just bash, nothing else. And now we are on the pod. Let me copy this command for reference. Put it here. So we are now on the pod. We do ls. We see like there's a pip file log, ping. I can do cat ping to see the content of the file. And what I want to run here actually is I want to try to access the service, TensorFlow serving clothing model using this URL. And typically what I would do is I would use something like curl and then send the request to, so I'll first do it with localhost and then it's 9696/ping. Yeah, so it says curl is not found. The reason is it doesn't have curl. So let me install it. It's apt install curl. I need to do apt update first. This is taking forever, probably because there are not enough resources for this operation to complete. So let me stop it. What I'll do now is I'll give the ping deployment a bit more resources. I'll give it 128 megs of RAM and 0.2 CPUs. I hope this will give us sufficient CPUs that we can use for the gateway deployment. So let me recreate it. First, I'll do kubectl delete -f, then ping deployment, and then I'll do apply. Now I do kubectl get pod, so it's running. Let me try to log into that one. So here I do apt update. Okay, now it's faster, yeah, probably because that one didn't have sufficient resources. So, and now I do apt install curl. And now let me use curl to do request to localhost 96.96/ping. Okay, it replies with ponk. What I'm doing right now is I'm in this container right now, and within this container, I am trying to send a request to a service that is running on this container. But now I want to send from this container. When I am here in this container, I want to send the request to the service, and then the service, of course, will go back to this container and execute this. So let me do it now. And remember, I told you that the pattern is first the name of the service, which is ping. Then we have the name of the namespace, which is default. Then we have SVC, then we have cluster, then we have local. And for this service, let me actually check it. So for this service, the port is 80, which means we can just drop this because 80 is the default HTTP port, and we can execute this command. And now it replies with ponk again. You can see it here. So this way we were able to send requests to the service using the URL, the DNS name for this service. And it kind of did a loop. So it sent the request to the service, and then the service sent it back. But this is how we can use the name of the service. Now let's try to do the same for our TensorFlow model. So for our TensorFlow model, we have this service, but we cannot really use curl for that, because if we try to do that, then it's trying to send HTTP GET request, but TensorFlow serving application doesn't want to deal with this kind of request. That's why it says it's not allowed. There is a different way of testing that actually there is something listening on this port, and we can do it with a tool called Telnet. So I'm not sure it's installed. It's not installed. So let me do apt install Telnet. I think we have it now. It's a very low-level library that allows us to connect to any port and then send something to this port. So let me do telnet, then URL, and then the port. And now we see that we are able to connect to this thing. And now it brought us something, and we can start writing something back, like hello TensorFlow serving. And then, of course, it doesn't know what to do with this information, and it just closes the connection. But what we verified by doing this is there is actually something we can reach this service using this URL and this port, and there is something actually running there, listening for this port, listening for requests, and we were able to communicate a bit with this thing, even though it didn't want to reply back. So the main thing here is it's reachable, and this is what we should use for the gateway service to communicate with our TensorFlow serving model. So let me exit this. And now I want to do kubectl apply gateway deployment. I hope we have enough resources. For ping, we gave it 0.2 CPUs. Yeah, let's see if for gateway 0.1 will be enough or not. Because I think if I give it more, then we will not have sufficient resources. Let's try kubectl apply -f gateway deployment. So it is created. Let's see, kubectl get pod, and it is running. So we have sufficient resources, which is a good thing. What we can do now is we can again try to forward the port from this pod, from the gateway pod, to our host machine, and then execute a command. So let me do that. Kubectl port for then the name of the pod, and then the port is 9696, and we map it to port 9696. Now I go to a different terminal, and I want to execute this test.py. So if you remember, it's just sending a request to localhost 9696, and let's see what it shows us. Python test.py. Okay, something is wrong. Let's check. What we can do is we can now see the logs from this pod. I will stop port forwarding here, and I'll do kubectl logs, and then this gateway service. It doesn't show us anything. I'm not sure what the problem is. So let me do port forwarding one more time, and I'll do ipython and execute this test thing manually. So let me copy all these things, and then I'll do requests post. Let's see, result is response 404, meaning it doesn't know what /predict is. So the problem is that I'm forwarding port from a wrong pod. So let me do kubectl get port, and then we actually need gateway, not ping, of course. Okay, now we do it one more time. This time it works. Phew. That's cool. Let me stop it. Now we have the deployment. Now we want to have a service for this deployment. So let me create another file. We'll call it gateway service YAML. And then it's a service, Kubernetes service. Then the name for this service is gateway. The port, let's use again 80 like we did with the ping service. And then we map it to 9696. And let's deploy it. kubectl apply -f gateway service. Now I do kubectl get service. So we have the gateway service. Actually, type is cluster IP, but remember we want the type to be load balancer. So let me select type load balancer. I'll do kubectl apply again and get service. So now the type is load balancer, external IP is pending, but it will always be pending. And if we had this external IP here, this is what I would take and copy to our test.py file. And this is what we will actually do in the next lesson. But now what I'll do is I'll again do port forwarding from the service to our local host, and then I will just execute this test.py file again. Service/gateway. Now I want to map port 8080 to port 80 on the service. And let me run Python test one more time. What is wrong now is that it tries to connect to a local host port 9696. Of course, it doesn't work. So I'll replace the URL now with 8080. Let's run the test one more time. And now we get the response. So what we did now is we deployed 4 things. So we first deployed a deployment for TensorFlow serving model. Then we created a service for that. Then we logged into one of the pods we have, and we tried to make sure that we can reach this service using the DNS name, the URL of this service. So we tested it. Then we created a deployment for the gateway. And in the deployment here, the important thing is that we specified the environment variable. We specified the URL, this DNS name, to the model service. After that, we created a service for the gateway, and we tested it locally by forwarding the port from the service to our host machine. And then we were able to send a request to this port and get back the response. This way, we deployed the whole thing locally to our Kubernetes cluster that we created with Kind, and we saw that it works. What we can do now is we can actually take all the config files that we brought already, we tested locally, we verified that it works, and we can deploy them to the cloud. We'll use EKS, which is a Kubernetes cluster from AWS. So we can just create a cluster there, apply all the files we created there. Yeah, that's what we will do in the next lesson. There is one thing I wanted to mention. It's related to communicating using gRPC. So gRPC is not usual HTTP, and there are some caveats for that. And one of them is load balancing with gRPC. Load balancing is a process when we have this service, model service that gets some requests, and then it needs to route the request to one of the pods. So this is called load balancing because it kind of balances the load the request it gets between multiple pods. There is one thing with gRPC and load balancing. So if we Google Kubernetes load balancing gRPC, then the first thing I have in my result is gRPC load balancing on Kubernetes without tiers. Because if you try to deploy a similar system in your settings on real Kubernetes, you might see a problem that this page actually describes. And the problem is that when you create multiple pods, not all of them will get the same amount of requests, the same amount of load. With default settings, Kubernetes fails to distribute the load evenly across all the pods using gRPC connection. So I will not go into details about that. This is something I just want to mention, that if you deploy something like this that we discussed in production settings, you might come across this problem. And this article describes what you should do if you have this problem. Yeah, it describes why it happens and how to solve this problem. So I'm sure at work, when you need to deal with Kubernetes, you will have people who know how to deal with Kubernetes, and you should sit down with them and talk about this problem, and they will tell you how to solve it. That's all I wanted to mention about this. And what we'll do next, as I said, we'll take all the config files we wrote now in this lesson and deploy all these things to a Kubernetes cluster on AWS. So see you soon.